Hey guys, in this video I'm just gonna quickly cover through some of the pressure questions on the 2021 Level 1 Mechanics paper. So this is an external, and so I'm just gonna start off by giving a brief explanation for pressure, and then how to calculate it, its units, and then we'll just move on to the problems from last year's external. So pressure defined is a force exerted over an area. So the equation that represents that is called is P equals F over A, where F is the force, right? And A is the area. Now don't get A and A confused. They're two different things. The lowercase can represent acceleration, and the uppercase can represent things such as area. And force, well, we can just assume that in most cases, it will be force of weight, and then that's mass times gravity, and G equals 10 meters per second squared. G is the acceleration due to gravity, and mass is in kgs, the amount of matter in an object, and force of weight will be newtons. So just a quick run through, the units for force will be newtons and meters squared. So the preferred units for pressure is pascals, and it's written by PA, or basically another way is that we can say that 1 pascal is equal to a newton per square meter. So that's also another unit. So you could write, for example, if your answer was 4,000, then you could write either 4,000 pascals or 4,000 newton per square meter, and you'd still be correct. So let's move on to this first problem here. So to get back to her car, Zoe wears snowshoes. The surface area of one snowshoe is 0.15 square meters, and the surface area of one walking shoe is 0.03 square meters. And they have very nicely already calculated the weight, her weight force, which is 570 newtons, and that's all we pretty much need. And it asks us to calculate the pressure on the snow. I'll just quickly highlight some important things, such as the surface area of both shoes and her weight. So for this first one, we know that since pressure equals force divided by the area, and then that equals 570 divided by 0.15, and that equals 3,800 pascals. Now, make sure they ask you, like, how many, like, typically when you think about a human, right, we've got 2 feet, so that'd be, like, calculated for both snowshoes. So make sure you don't multiply the area by, you don't convert it into, you don't multiply it by 2, so instead of it being 0.15, you put in 0.30 square meters, and so just make sure to read that part carefully. Then the next one would be same thing, P equals F over A, which then equals 570 divided by 0.03, which should equal 19,000 pascals. So that's for that part. Now, this next part here is explain why using snowshoes makes it easier to walk in the soft snow. So we know that her weight force remains constant, and the only thing that's changing here is the area. Now we can see that the snowshoe has a greater area than the walking shoe, and hence that just basically means that her constant weight force is divided over a greater area. So it's not all confined into one space, it's all spread out, which means that realistically the shoes won't be sinking into the snow too much. So what I'll quickly do is I'll type up an answer and then I'll show it to you guys. So So here's my explanation I've written up. So since Zoe's weight force remains constant, the only thing that realistically changes is the surface area of the shoe. So when she is a snowboard, there's her constant weight force spread over a greater area than compared to her walking shoe. As a result, her snowshoe does not sink into the snow as much. I also, just before I end this video, I just wanted to quickly clear up one thing back in the units. In case if because when we put it in, A must always be the area that you must always put it in meters squared. And sometimes what happens in these externals is they may put it into a into square centimeters. So you just gotta be aware of that. And if you do get centimeters squared, then to convert from a centimeter, a square centimeter, you just have to divide that. If you get an answer in square centimeters, just divide that by 10,000, I think, to get the answer in meters squared. So make sure you're always looking out for that. And apart from that, that's pretty much it for this pressure section. There's no other equations related to pressure that you need to know at this level, and I've covered the units. I've gone over a quick question, and yeah, so thank you very much for watching.